How's everyone? I cannot see anyone. How are you all? Good? Okay, that's good. I'm very excited to be here. We have many stuff to talk about, so let's just begin. And this is not the clicker, so it doesn't work. All right. Once upon a time, and actually it's not that far away from here, and it's not that long ago, that machine learning was kind of a magic word, right? So it felt like for me that someone wanted to say that their app is doing something that is smart, or that their technology is innovative, or that they do something new or something cool or anything like that. They would just say, we do blah, 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 AI. We will do blah, 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 ML. This is how it felt for me, and they would say these kind of things even if they didn't know what it means, even if it wasn't really true. They would just say it because it sounds good, right? Today I'm here to talk a little bit about what it means and how can we actually use ML in our app very easily and nicely and in a very useful way. So after this whole magic word was out there, and it didn't mean anything for us for, I think, quite a few years. For that reason, actually, one of the most exciting announcements in I/O this year for me was MLKit. MLKit, which is still in beta, actually allows us to have, in a very nice and easy wrapping, machine learning capabilities, and in a few minutes we'll discuss what it really means, in our app. Basically the same way that up until now we were able to say, OK, I need to download an image, for example. So hey, library X, please encapsulate all the magic, all the heavy lifting, all the management, all of this crazy stuff that you're doing behind the hood, and just do that thing for me. Or if I needed like analytics in our app, for example, I could say, all right, library Y, please encapsulate all the magic, all the heavy lifting, all the management, all the crazy stuff that you're doing behind the hood. Encapsulate everything, just do that for me. So now we're actually able to say, hey, I need ML capability in my app, so please, MLKit, encapsulate all the magic, all the heavy lifting, all the management, all the crazy stuff that you do under the hood and behind the scenes, and just do that for me. So this is why this announcement was really, really cool, and I really like this tool a lot. So I wanted to introduce it to you a little bit with some intro and background around it. I'm not going to talk a lot about what ML, what does it mean in general, ML capability, how does machine learning works. I have a series of talks and blog posts and workshops that are called Who's Afraid of Machine Learning? So you can search for that. And there has intro for developers about what is machine learning, how does it work, a little bit of deep learning and stuff like that for developers like us. I created this talk and this blog post basically because, as I said before, everyone was excited to talk about machine learning. And me, as an Android developer, I was kind of afraid of machine learning because everyone were talking about it, and I didn't know what they mean. So basically, this is how I wish all these topics have been explained to me as a developer. Max had said before, my name is Britt. I'm a DD for Android, so not for machine learning and not for, I'm not a data scientist. I do not have a PhD in anything. And from this developer's perspective, I'm here to talk to you a little bit about these topics. I work for a company called Nexmo on the developer experience team. I'll talk a little bit about what we do. We have all kind of communication services, like talks, IP calls, PSTN calls, video calls, all kind of this stuff. And we'll see some example on why does it have to do with what I explained to you today in a few minutes. All right, so as I said, I'm not going to talk a lot about machine learning like in general, but the way I like to explain this kind of stuff is that basically human beings since forever have been always very fascinated about how nature works and how can they use it for their own benefits. So for example, when humans wanted to create a machine that can fly through the air, what did they use for inspiration in nature? Birds, right? They used the chest and the wings of birds to create airplanes. And when they wanted to create machines that can detect objects underwater where you barely can see anything, what did they use for inspiration? You're good today. Yeah, they could use bats and dolphins in order to create sonar system. There's a nice train that is called the bullet train, if you've heard of it. It's very, very fast. It's really, really loud. And in order to fix that, how much loud it was, scientists used a small bird called kingfisher, and they used the head and its beak in order to fix the structure of the train and to fix the loud sounds it makes. So there are tons of examples for all these kind of things that humans have been taking inspiration from many things, animals, but not just animals in nature, in order to create technologies and industries around us. Many cool stuff. Maybe one more example that I really like is that in order to get inspiration about all this crazy and innovative screens that we use today, scientists, do anyone have any idea? What's the inspiration for that? Max, no? Nothing? Inspiration for new technologies for screens, multimedia screens. No? So what? So actually they use, it's very close, they actually use the wings of butterflies. The wings of butterflies are actually transparent. They have no colors and no patterns and nothing like that. But they have small scales on them. And the scales actually make the light scatter. And this is how the colors and the patterns, this is how we see them. So it's really cool, I think so. So we have been taking inspiration from nature about tons of stuff, and then to create machines and stuff like that to be useful for us. And then when humans wanted to create a machine that can learn, so it needs to take a lot of data, process the data, and then make conclusions, and actually get better and better and better, and create better conclusion and more accurate conclusions. What did they use for inspiration? What could we use in nature? What learns what thinks? Yes, the brain, right. So once again, I'm not going to talk a lot about the human brains because you can find on my blog post the information about that and a little bit how it works. But basically, scientists know like Figment about how the brain works, but they use the process that we think and we learn and we create conclusions in order to create machines that can do the same things. So I said before that once we could have just say, I need to download an image and take library X and do that with the library to download the image. But what is actually the difference between, for example, downloading the image and, for example, figuring out what's in the image, or classifying or labeling the image? It's different words to actually to say what's the object we see in the picture. Why is this machine learning and the other one is not? Basically, downloading an image, for example, the way to do it is basically an algorithm that it's pretty much static and it's pretty much like finite. And it takes the input as it is. So for example, the URL that we want to download, and could be the network situation and the resources that we have, maybe how much battery do we have, if we're on Wi-Fi, stuff like that. So like finite stuff like that. And then we go through the algorithm. So a bunch of steps, one after the other, a bunch of instructions in order to download the image. Basically, this is all the processing that we do with the input in order to get to the final thing that we're trying to do, in this case, to download the image. But how does classifying an image work? Once again, classifying means like figuring out what do we see in an image. What is this object that we see in an image? How does that work? So a little bit about that. Let's try to think, how would you teach a baby that what he sees in the image? So for example, if a baby that just is new in this world, you would want him to learn how to classify or to understand that on an image they have a strawberry. So you won't just take the image and tell the baby, okay, you see this image? This is a strawberry, right? It would not, this is not how he would learn that this is indeed a strawberry, right? You would say something like, all right, do you see this image? So this is a strawberry. Why is this a strawberry? Do you see that the object is mostly red, and it also has the seeds kind of pattern on the red, wherever it's red. And then, like on the top of it, just above, there are green leaves. They are like narrow-shaped. And if you look at the object, the red object shape, it's basically pointy at the bottom, but on the top, it's like round. So all these features, and because all of these features, we can get to the conclusion that this input or this image is of a strawberry. And basically, even if you would not do all this deconstruction of the features to the baby's brain would kind of do the same thing by itself. And we actually do that all the time, even some features that are not that conscious, but this is how our brain works. Try to figure out features, and then with these features, we actually are able to understand for each image if this is a strawberry or this is something else that we see in the image. Basically, this is a little bit why is this kind of different, downloading an image and understanding what's in the image, the deconstruction and how we treat the input. And I have been talking about images, and we will talk about images mostly in a few minutes when we start talking about MLKit. But I do want us to understand that when I talk about machine learning capabilities, like in general, it's not just images. So here we'll discuss images, but machine learning capabilities can be also like getting voice and understand what are the words that we hear in this voice, or what emotions do we have from the tone that we hear. And things like that are also different kinds of machine learning capabilities. But now, and for MLKit, we'll focus on images and what can we get from the images, what information do we have there on the image, on the objects that this image represents. OK, so MLKit basically currently have a vision library, because I told you that what we currently want to do is just take images and figure out some information there. It has, for all of the APIs, for some APIs they have, and we'll see the APIs in a second, for some APIs they have models or an ability to do this detection on device. For some, they have this ability to make the decision-making on cloud. We'll see in a second what's the differences and what's better for each use case. The APIs or the use cases that are just out there, out of the box for us to use, are as such. We have text recognition, which basically means take an image. We'll see how to use it in a few minutes. Take an image, and to extract the text that it has inside. And then we have face detection. This is not a face recognition, which means taking two images, for example, and understanding that we talk about this is like the same person in each image. So it's not that. Face detection basically means to understand that in this image we have a face, and it would give me like, where are the eyes, where are the features, where are the eyes, where is the nose, if I'm smiling or not, what is the angle of my face, stuff like that. This would be on the face detection. Barcode scanning, taking a picture of a barcode and then extracting the information that this barcode has. We have image labeling. Once again, we'll discuss that in a few minutes, which is what we said, taking an image and understand what are the objects that are in this image. And actually, if we have landmarks in the picture, so famous sites and stuff like that, we can even get more information, like what's the geolocation and stuff like that. So we can get even more information about the object or actually the landmark, the place, the location that is on the image. Now, if none of these use cases work for you, there's also a very, very, very nice very nice ability to use custom models. So if you have your own custom model that maybe not you did, but basically you're a data scientist, or you have it maybe downloaded from like open source, you could take this custom model, if it's of TensorFlow Lite or TensorFlow, and then you can convert it to TensorFlow Lite model. You can basically host it on Firebase and then use it from your app, which is very cool and very nice, but we'll not go into many details about that. All right, so let's see one example in order to see how really simple and fun and useful this thing is. So this is a real story. I want you to meet someone that I really love because I feel like, oh my God, oh, I ruined everything. So I feel like we're already friends, me and you. So this is my grandmother. Her name is Esther. I really, really, really love her. I go to visit her every Saturday, except for tomorrow because I'm here. So, so I go every Saturday to visit her. We drink coffee, we eat ice cream, all this kind of stuff. We talk about guys, we talk about everything. I kid you not, she's amazing, she's awesome. And then one day, a couple of months ago, I came to her house. I sat with her and my grandfather. We made some coffee and stuff like that. And then I opened the freezer. And what did I see? This thing. And I was like, Grandma, what is this? A pistachio ice cream? You're a chocolate girl. What is this? And then she looked at me and told me, because we talk about everything, she said, you know, lately, I'm not able to see as good as I used to, and it really bothers me. But you know, when I'm on the grocery store and I'm choosing for ice creams and I can't really see what it says sometimes, like what the labels say, and I don't want to bother people, so I'm not gonna ask anyone what it says. So I just picked it up and I figured it would be fine. And then I thought, oh, I want to help her. How can I help her with a very, very, very easy way? So I wanted to create an app for her, which honestly took me a couple of hours, not more. That basically I thought what we can do is like this. If I had a very simple app that she can take a picture from whatever she sees on the grocery store, and then I'd have some detector, which would go to one of Firebase's APIs from MLKit, and say, hey, take this image that I just made, please detect what do I see in this image. So in this case, I'm talking about the text. I want to detect the labels. So I would expect a result which would be a string. And I wanted to say something like Ben and Jerry's, right? Ben and Jerry, pistachio. So I could know that, I mean, she could know that this is pistachio ice cream and choose something else maybe. This is very good because it's going to be a string. So I can basically take the string. It's easier for me to put it on a UI that I can control the contrast, that I can, you know, have a larger font, make sure she can see that, but actually it's very simple for me to, I don't know if you know all the text-to-speech features and all this kind of stuff, push-to-talk and stuff like that. Basically, it can read the text to her. That if it was just in an image, it wouldn't have been possible. So this sounded like a good idea for me to do. And really, I want to show you how simple this is to actually execute. So what I need to do is actually first thing is to set up the detector, or basically to figure out, to decide which API from Firebase MLKit do I want to use. Now, first question is to decide if I want to use a local, meaning on device, or on cloud. Remember, I told you that mostly I can choose between those. So what is the right solution? Let's talk about that for a second. So I told you before that I work for a company called Nexmo, and we have all kind of libraries for communication. So we have video chats and IP-to-IP call and PSTN calls and in-app messaging and stuff like that. If I would want to use this, any one of the APIs real time in a video chat, for example, I cannot use a cloud-based models, right? Why? What do you think? What? Yeah, it's going to take a lot of time, because if I'll take a frame and send it to the cloud on the network, don't know, even if the network and the bandwidth is amazing, it's going to take some time until the result gets back. Usually, like, the frame would not be relevant anymore. So if we want to do anything that is real time, we have to go for the local or the on-based scenario. So this is for sure. Also, you know, sometimes there's one grocery shop that my grandmother goes to, and there's like the connection there is really, really bad. So mostly, if she just go there, it's like on the basement, it's offline. And then she would not, like, if we have to use the cloud and the network, she would not be able to use the app at all, right? So for this kind of situation, if we have something that we have, that we want the users to use, even if they're offline, we would have to go for the on-device solution, right? Also, if there are some security or privacy, maybe the items that I'm taking picture of are like a little bit private, not, I don't know, groceries and that's it. Maybe we don't want to handle privacy and security things. Maybe the bandwidth is too expensive and stuff like that, and then I would have to go for the local or the on-device solution. The cloud solutions, though, so the cloud-based models, I promise you, and we'll see in a second, they are a lot more accurate, but also they tend to have more features. So, for example, if we talk about the text detection is good for Latin languages, but I'm from Israel, and my grandmother speaks Hebrew. So in order to support Hebrew, for example, I have to go to the cloud solution in this case. But also, as we said before, it takes more time. So this is a trade-off that we need to do. We developers have to take into account and to do whatever we want. Another very small but important thing that you should know, that if we use, I think, more than 1,000 calls a month, something like that, in the cloud calls, then it starts to cost us some money. So, so we have to take this into account as well. Anyway, we decide on a detector, and we set up the detector. What does it mean to set up the detector? It's extremely simple, I swear to you. Basically, is to call FirebaseVision. As I told you, all the APIs currently are under this library, FirebaseVision. So we get an instance of that, and then we just decide on-device text recognizer, or I go to the on-cloud one. And that's it. This is how we set up the detector. And now, I need to process the input. So the Firebase MLKit APIs, they cannot understand regular bitmaps or anything like that. So we would need to obtain a FirebaseVision Image object. I can obtain it from a bitmap. If I work with something that is saved, an image that is saved on my device, so I can just use the image URI and do it. It's just as simple. And then I have media image. So if I use the camera, as we saw before, for like video chats and stuff like that, I can use that. Also, byte array and byte buffer. Once again, it's as simple to use. So I just create an image, a FirebaseVision image. That's it, with one line. And this is an input I can actually use. So all that's left for us to do is to basically execute the model. In this case, to understand what is the text that I have on the image. How do I do that? I just ask the detector to execute, to process the image. And of course, it's an asynchronous task. It would take some time. So I would need to attach a listener. I attach an on-success listener. I can do it the same with on-failure listener, for sure, of course. And then this is where each one of the APIs, this is the only place, basically, that it's really different from one another. And this is the object that we get in the end as an output. So in this case, the output that we get is of the object of the type FirebaseVision text that actually has, it's really nice. It's really nice, it's really easy, simple to use. So it has blocks. And then lines, so and then like the words. So actually, theoretically, you can just ask, OK, give me the second word in the third line, something like that. So it's really, really nice. But if we want to keep stuff simple, we can just ask for the text. Just do like get text from this object, and then you'll get all of the text with separate lines and stuff like that. So it's really cool. It's really nice. All right. Now we can do with that whatever we want. So for example, just put it on some text view, but that's it. Let's see some results that we got. So if I ask for this detection for this image of the ice cream pint, I do want you to notice that I'm not making it easy for the detector, because the font here is a little bit crazy, like the Ben & Jerry's and stuff like that. It's not like something that you'll find on just regular signs and stuff like that, right? So it's a little bit like crazy. It's not making life easy for the models. But anyway, if I run it, so if I run the local model, I don't know if you can see it. I will tell you what it gives me. So the time was a little bit below 300 milliseconds. So it's really, really quick. And it says that we have here a pint of Ben & Jerry's pistachio. What do you think? Makes sense? So actually, if my grandma already knows that basically she's on the, she's trying to choose an ice cream, so she already has the context, maybe this is enough. Because, fine, it says Ben & Jerry's, but like she can understand what it means. So maybe, and if we want something really quick and offline and so on, maybe it can be enough. If I run the on-device, the cloud-based model, it takes like a second more, as you can see. But now it already knows that it is Ben & Jerry's and it's pistachio ice cream with roasted pistachios. So it knows everything. So it's really, really nice, even though the font was a little bit messy. All right, so this is about that. I want to show you very quickly another example. And basically, it's just for you to see how simple and quite similar it is to use each of those APIs that I showed before. So let's take the labeling as one example. The labeling, as we said before, basically means what objects do we see in the image. And what I expect to see here is basically I would take the same image, I would ask the detector, and now it would be a different detector, hey, just execute on this image, please. And then I expect it to give me a result that says something like, this is an ice cream pint. Something like that. Let's see, what could this be used for? So basically, labeling is very good in order to get a category of the image. So if you want some categorizing, filtering, searching, anything like that, it's a very good use case to use this kind of thing. Also, and kind of as before with the images, if I would want, for example, to get some information about what some of the interests of my user, in order to suggest new things for the user or anything like that, think how simpler and lighter it is to send just the text, the simple text, the plain text for the labels, rather than to start sending images. So it makes everything lighter, right? All right. So once again, the goal here is to see how similar it is, because most of the APIs are really, really simple to one another, and I really want to encourage you to take a look at those yourself. So how do we set up the detector? It's pretty much the same. We go to the FirebaseVision library again, get the instance, and then just pick the detector that I want. So now it can be the vision label detector for the on-device one, or we go for the cloud-based solution, which is pretty much the same. And then I need to process the input again, once again, and with all of the APIs, I need to obtain a FirebaseVision image the same way that we did before. Now we just need to execute the model. It's done the same, exactly the same. I'm going to add the on-success listener, exactly the same. And as I told you, the only difference would be it's a different model, so we're going to get a different output, a different result at the end. So now the result is the FB labels, so like the Firebase label. Each label, this kind of object, contains a label. So this means like ice cream, apple, whatever. The confidence, so how certain the model is that this is indeed an apple or this is indeed a strawberry. So we'll get a float between 1 and 0, and an entity ID that basically is the entity ID of the Graph Knowledge API, so we can query for that and get more information about that. Now we can do whatever we want with this information. For example, just set up a string, construct a string, and put it on the UI. Pretty simple. Simple as that. Let's see a little bit some result, how we did with that. So if I got, this is a little bit of a different image, but once again, it's pretty much the same. And first I run the local model. So for the local model, it's pretty nice. It knows that this is food. Once again, it's pretty general. So if I needed to do some general categories, this would be pretty nice. It took, I don't know if you can see, it took a little over a second and a half. All right, and if I run the cloud model, this took more than 3 seconds. But now it already knows that this is probably ice cream, this is probably a dessert, frozen dessert. So it's pretty cool. It knows, it knows pretty much what it is. All right, and the numbers are basically the confidence that we saw before. All right, so basically for now, this is kind of all I have for you today for now. The goal here is really for you to kind of see how simple it is to use, how useful it can be for your users, and also for the people you love to create very simple apps that can be extremely useful for the day-to-day life, like my grandmother. And that's pretty much it. As I said before, some more information and code snippets and stuff like that, you can find everything on my Medium, so feel free to do that. I'm here for questions, and I'm here at the conference for questions and everything, but of course also you can feel very free to contact me on social media, so keep in touch. And that's it. Have a great conference. Thank you so much.